Hello friends, welcome to my channel. Let's have a look at problem 2335, minimum amount of time to fill cups. So for this problem, actually the code is not essential. Here our purpose is to give a rigorous analysis. So we saw some solutions, but we feel that those solutions are not rigorous. So here we hope that we could do a rigorous analysis. So I will directly go to the analysis without reading through the problem statement. So actually we only care about the types of the cups. We do not need to know whether it's cold, warm, or hot. So assume that after we sort from small to large, the three types of cups are A, B, C. A, B, C both representing the type and also representing the number of cups. So we would like to distinguish the two cases. The first case is easy. So the case is when A plus B is less or equal than C. So in this case, we just need C seconds to get the task done. The strategy is the following. So each time we fill a cup of type C together with a cup of either type A or type B, if there are type A or B cups. Otherwise, we just fill a single cup with type C. So that way, we need in total C seconds to get all the cups filled. So that's case 1. So case 2 is slightly harder, but it's still easy. So it's corresponding to the case A plus B is strictly larger than C. So let's first exhaust type C cups by C seconds. So the strategy is as follows. So each time we use a type C cup together with a type A or type B cup. But we know that after we exhausted type C cups, there are still possibly type A or type B cups. So therefore, we need to optimize the number of cups of type A and B used. So the remaining part actually is analyze the optimization task. So to optimize, so let's assume that we have used X type A cups and Y type B cups. So we know X plus Y should be C, right? So after the above operations, so type C cup already exhausted, and type A cup remains A minus X, and type B cup remains B minus Y. So this is trivial at our assumption. So as we would like to use 2 cups as long as possible, so we need to minimize the difference of the remaining 2 types of cups. So in other words, we need to minimize this quantity, the absolute value of type A, that is A minus X, minus B minus Y, this type B. So with the constraint that X plus Y equals C, and X greater or equal than 0, Y is greater or equal than 0. And actually, it's implicitly implying also A minus X should be non-negative, and B minus Y should be non-negative. So here we want to take off this absolute value. So because after we sort, B is greater or equal than A, actually we should first exhaust type A. So we can assume without loss of generality, B minus Y is no less than A minus X. So this absolute value will be B minus Y minus A minus X, right? So then we know if we break the parentheses, we are going to get B minus A plus X minus Y. So now we want to use the relation X plus Y equals C. So we can write X here to be C minus Y. So together we are trying to minimize B minus A plus C minus 2 times Y, right? So that's the final expression. Notice that here A, B, C, and Y are all integers. So the best of the Y is for sure the C plus B minus A plus C, or C plus B minus A, integer division by 2, right? So that's the thing. So once we realize that, then after we have taken C seconds to exhaust type C cops, then we need an additional B minus Y seconds to finish the remaining type A and type B cops. That is B minus this Y, right? So that's the full analysis. So basically we sort this all from small to large, and then we distinguish two cases. One is A plus B less or equal than C. So this case is trivial. We just need C seconds. And the second case is A plus B is larger than C. So this case needs some thoughts, and then we find that we should use C plus B minus Y. This Y is computed here from the optimization problem. So that's about it for this problem. So I guess for this problem, the code is not essential, but the analysis is more important. So with the above analysis, so we can write the code. So it's like a verbose translation, right? So we thought this list. So we have changed the function signature or argument as A for the ease of writing or analysis. So after we thought, we check this ABC in order to align with the above analysis. Then we consider the two cases. First is A plus B less or equal than C. We return C. And otherwise, we get the optimized Y, and then we return C plus B minus Y. That's about it for this problem. Thank you very much.